Section 9.1 Correlation. A correlation exists between two variables when there's a relationship between the two. The data is called paired data because you measure two different things from the same person. For example, a person's height and shoe size. A positive relationship means that as one variable increases, the other also increases. Examples: how much electricity I use and my bill. The more I use, the more my bill goes up. Miles run and calories burned. As the number of miles increase, so does the number of calories. A negative relationship means that as one variable increases, the other decreases. Okay. Car payments and balance. As the number of car payments made increase, the balance left decreases. The weight of a vehicle and fuel efficiency. As the weight of a vehicle increases, the fuel efficiency decreases, miles per gallon. Okay, think about my Nissan Altima gets like 30 miles per gallon. Okay, but a big SUV, like a big Chevy Tahoe, is going to get like 18, 19 miles per gallon. No correlation means that a pattern does not exist. Two variables are not related. Height and IQ. Okay? There's no relationship between somebody's height and their IQ. Shoe size and number of children somebody has. There's no connection there either. Okay? A linear correlation coefficient is a method to calculate the relationship of correlation. The values must always be between -1 and 1, and we use R for the correlation coefficient. If R is -1, okay, we'll say correlation R. If R is -1, it's a perfect negative correlation, and that means there's no exceptions. 0 means no correlation, and 1 is a perfect positive. The closer it gets to -1, the stronger the negative correlation. The closer it gets to 1, the stronger the positive correlation. Numbers that are close to 0 indicate there's no relationship. Think about a number line. Okay, no correlation would be 0. The further right you go, the further you get to 1, the stronger the relationship. Okay, the further left you go in the negatives, the stronger the negative correlation. Okay, think about car balance and car payments. Your balance is going to always go down when you make a payment. Okay, so there wouldn't be any exceptions there. When you're comparing correlation, -0.95 and -0.75 would both be negative, but -0.95 is stronger since 0.95 is closer to 1. Okay, let's say since -0.95 is closer to -1. 0.75 and 0.95 are both positive, but 0.95 is larger, so it's stronger. Okay, no correlation are numbers close to 0, like 0.25 or -0.34. The stronger the correlation means the graph looks closer to a line. Positive goes up from left to right, and negative goes down. Okay, there could also be a pattern, but if the pattern is not a line, it's not called linear. The explanatory variable is x. It's what affects the other thing. The response variable is y. It's the variable affected by x. Okay. Like we talked about, as electricity increases, so does my bill. Okay. The explanatory variable is usage, and the response variable is the bill. The usage affects the bill. Okay, so graph A is perfect positive. R would be close to 1. Okay, it's an exact straight line. Okay, B is strong, but it's not as close together as a line as A, so maybe like 0.9. C is moderate. Okay, it's sort of a line, but it's not as close as this example B. Okay, so maybe 0.4. D is a perfect line going down, so it's close to, so it is -1. It's a perfect line. Okay, let's look at E. E is strong negative. It's not a perfect line, but it's pretty good, so maybe like -0.9. F looks like a line going down. Okay, it's not as good as E, so maybe like -0.4. G is not close to a line at all, so that would be close to 0. D is a pattern, but it's not a line. Linear means line. Okay, so that's close to 0 as well. Okay, we have to be careful about interpreting correlation coefficients. Just because they're correlated doesn't mean one causes the other. Okay, we say correlation does not imply causation. There are many good examples where it doesn't make sense. Ice cream sales and shark attacks. The common response means both things could be affecting, something could be affecting both of them. Okay, ice cream sales and shark attacks. Ice cream's not affecting how many shark attacks there are, but both increase because, and when the temperatures increase, more people are in the water and more people buy ice cream. Okay, other factors probably affect both. Okay, so what about cola consumption and bone density? We can't say for sure that it's drinking Dr. Pepper that affects the bone density. It could be somebody's eating habits in general. Okay, scatter plots plot the data on a graph. The explanatory variable is x. Okay, so that would be going left to right. The response variable is y. Okay, we can see there's no relationship between shoe size and IQ. There's no pattern there. Okay, how about hours of exercise and resting heart rate? Okay, so it appears as hours increase, which means going to the right, the beats per minute resting heart rate goes down. Okay, another example, education and income. As education increases, so does income. We can see a nice little pattern of a line here. Okay, note that income here in this graph is in the thousands. Okay, income in thousands. So that first line, that first person has 12 years of education and 22,000 income. Okay, now you see these two dots that are outside. Okay, two dots that are outside this general line pattern. Those are called outliers, and those are just exceptions to the rule. Okay, so the first one, the first asterisk there, 14 years of education, $2,000 in income. There could be lots of reasons for this. They might be a stay-at-home parent. Okay, they could be still in school. The other outlier is this 11 and 97. So somebody with 11 years education and $97,000 in income. Okay, just remember, just because somebody doesn't have a college degree doesn't mean they won't make a lot of money. They could own a business that's very profitable. My neighbor that works for the power company, he's a lineman. He makes more money than I do. Okay, that's just how it happens. So there's exceptions to the rule. Okay, but we have just a general pattern like this. And that is section 9.1.